In this video, we're looking at a simple harmonic oscillator, and we're told the force that it takes to pull this thing 25 centimeters from the equilibrium position. That takes 32.5 newtons. And we're given the mass of the oscillator. In part A, we're going to compute the spring constant, and then in part B, we're going to get the frequency of oscillations when we let the thing go. So to get the spring constant, we're just using Hooke's law here. And I'm going to state that just in terms of magnitudes, so I just left the minus sign off. So we have F equals kx, which means the spring constant k is going to be the force exerted by the spring divided by the stretch distance for the spring. So just to clarify, when we pull this thing to 25 centimeters from the equilibrium position, we're applying a force of 32.5 newtons to it. But everything is at rest here, so the spring is applying a force of 32.5 newtons in the opposite direction. And that's actually the F in Hooke's law, is the force exerted by the spring. So that's 32.5 newtons. Our stretch distance was 25 centimeters. We convert that to meters. And when we run the numbers on this, we get 130 newtons per meter for the spring constant. In part B, we're asked for the frequency of oscillations when we release the harmonic oscillator and let it start to bounce back and forth. And I remember the formula for the period of oscillation, and I'll post a link to where this was derived real quick. And that's 2 pi square root m over k. Now the frequency is just the reciprocal of that. So that's 1 over 2 pi square root k over m. And we just plug the numbers in. Make sure to convert that mass to kilograms, 0.55 kilograms. Into 3 significant digits, we get 2.45 hertz, or 2.45 oscillations per second. And we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.